the video on Radian Measure. Let's first go over a few vocabulary words. We're going to start off with a central angle, and I know we've talked about this already a lot. It is an angle with the vertex at the origin. Okay, so remember that origin is right at the center of the circle, so it's a central angle. So this right here would be an example of a central angle. Okay. Good job, central angle. An intercepted arc is a portion of a circle's circumference, with endpoint on either side of the central angle. Okay, so a portion of a circle's circumference with endpoints on either side of the central angle. So points on either side of the central angle, and it's a portion of the circumference. That is the intercepted arc. Okay? A radian. So you've never talked about radians before, and now that you've looked at a unit circle, and you know that circles are both measured in degrees and also measured in pi, the radian kind of relates to the pi as opposed to the degree. Okay, so we're all pretty comfortable with the degrees around the outside of our unit circle, but now we're sort of tying those into pi and what that means. That's our radian measure. Kind of like saying the temperature outside is a certain temperature. We can measure it either in Fahrenheit or we can measure it in Celsius, but it feels the same to us. It's the same exact air temperature. It's just measured in two different systems. And so that's the same thing with our circle. So a radian is the measure of an angle whose intercepted arc is the same as its radius. Its intercepted arc has the same measure as its radius. This arc has the same measure as this radius does. Okay? Intercepted arc has the same measure as its radius. That is called a radian. Okay, so that means that this angle right here is a radian. Instead of a degree, considered a radian. All right? So as we deal with our circles, we're going to talk a little more about that. So what we're going to do next is we're going to convert different degree measures to radian measures and radian measures to degree measures. So you can get used to converting them from one to the other, because we will need to do that at times. Okay. Converting from degrees to radians. So the first thing we're going to do, though, is derive the conversion factor. I want you to understand how we get to this conversion factor, okay? So we start with degrees out of 180 is equal to radians over pi. So we look at a circle, and I know that because we just talked about the unit circle a little while ago, we talked about the fact that we have 2 pi radians in a circle. So over here is pi, right? So this would be 1 pi, and then we would have a second pi. So 2 pi in a circle. That is the radian measure. So 2 pi radians is exactly the same thing as a full circle, 360 degrees, okay? And so we have to kind of figure out how many pi radians are there in a circle. We would go ahead and divide by 2, divide 360 by 2. We get pi radians is equal to 180 degrees. So for every pi, there are 180 degrees. For every 180 degrees, there are a pi. Thus, this is what we use to convert. Okay, we have radians is equal to pi, or radians over pi is equal to degrees over 180. So that is how we derive the formula. Pi radians, 180 degrees. So let's practice using that conversion factor. We're going to go ahead and plug this into that formula and figure out, convert from one to the other. So that has a pi in it, which means that it is a radian measure. So it gets plugged in for r in my formula. So d over 180 equals 13 pi over 6 over r. Over pi. The 13 pi over 6 went in for the r in this formula, so over pi. So again, what do you do to solve a proportion? I think almost all of you know you're going to cross multiply. So you're going to do d times pi, and you're going to get d pi equals, and then you're going to do 180 times 13 pi over 6. Okay? 180 times 13 pi over 6. And so you're going to go ahead and multiply this, right? 180 times 13, and then you're going to divide it by 6, and you're going to get d pi equals 180 times 13 divided by 6 is 390 pi. So notice I leave the pi kind of hanging out on its own. I calculate all the number part, and I leave the pi. And then what you're going to do here is to figure out how many degrees it is, we're going to divide by pi. And when you divide one side by pi, divide the other side by pi, and we get d equals 390 degrees. Okay? Let's try a second one. Start again. So again, this is a radian measure, so it's going to go in for r. So d over 180 equals negative 3 pi over 2 over pi. And then make sure you remember that you cross multiply top to bottom, bottom to top. Okay? So we get d pi equals 180 times negative 3 pi over 2. Again, you're going to calculate this numerical part, and you're going to leave pi sort of hanging out by itself. 180 times negative 3 divided by 2, you get d pi equals negative 270 pi. I'll fix that for you so you can read that better. Negative 270 pi. And then divide both sides by pi. The pi's will cancel. D equals negative 270 degrees. So 270 degrees in the clockwise direction. Okay? So, lo and behold, when we convert to radians, we're going to do exactly the same thing, except now we're plugging these in for the d, because these are our degrees. So I have 150 goes in for degrees, so 150 divided by 180 equals r over pi. And again, we do the same thing we've been doing, cross multiply, top to bottom, bottom to top. So we get 150 pi equals 180 r, and to get r by itself, we have to divide by 180. You do that to one side, you got to do it to the other. And so then we're going to reduce this 150 over 180. We could cross the zeros out, and then these are both divisible by 3, right? And so you can go ahead and keep reducing, and we end up with 5 over 6 pi equals r. So 5 pi over 6, right? So we usually don't say 5/6 pi like we do when we say 5/6x. We say 5 pi over 6, or 3 pi over 2, or 7 pi over 8. It's just how we say it. Let's do the next one. we have 27 degrees, so 27 over 180 equals r over pi. And my markers are kind of big and take up some room, so I'm down here a little bit. We're going to cross multiply, top to bottom, bottom to top. 27 times pi is 27 pi. 180 times r. Again, to get r by itself, we got to divide by the 180. So we have to simplify 27 over 180. So we're going to get 3 pi over 20 equals r. Okay? So that is conversion from y to the other. Now let's go to the next page and do some exact cosine sine measures. So I'm going to give you an example at the top of the page, and then we're going to do these two examples otherwise. So the first thing we're going to do is we're going to talk about this example. So pi over 4 is my example. I want to find the exact measure of pi over 4. In other words, on my circle, I want to know what this is. My angle is pi over 4, and I want to know what this cosine and sine is. This is what I'm looking for. Okay? But I need to know how many degrees this angle is so that I can calculate it. All right, so I can find the exact cosine and sine measure. So pi over 4, I'm going to convert to degrees. So that's step number 1, convert to degrees. So d over 180 equals pi over 4 over pi. We're going to cross multiply, top to bottom, bottom to top. Okay, so d times pi is d pi, and 180 times pi over 4. So now I'm just going to do 180 divided by 4, and we'll leave the pi out, remember? D pi equals 45 pi divided by pi. So d equals 45. So this is a 45-degree angle, okay? So draw the appropriate triangle. So got my little triangle. That's kind of a really small picture to draw with these giant markers. Let me see if I can fix that up for you. I'm sure yours is better because you're using a pencil. This marker is kind of big. Okay, so that, maybe I'll put the 45 down here. So you're drawing in this triangle, and you're trying to figure out what that cosine sine measure is right there. Okay? And so we already know, if you look at your unit circle, at 45 degrees, what the sine and cosine measure is. So remember when we did a hypotenuse of 1 the other day with our triangle, when we were practicing our 45, 45, and we did 1 as the hypotenuse, and we said this is n, and this is n, and this is n square root of 2. And then we had to calculate, and we ended up with the square root of 2 over 2. And here we ended up with the square root of 2 over 2, right? So this would be 1. This would be the square root of 2 over 2. And this side would be the square root of 2 over 2. And so if I wanted to know what that measure was up here, I would go from the origin, right? When you're trying to get to this point, you do your x-coordinate first. So I went over this distance, which is the square root of 2 over 2. And then I went up that distance, which is square root of 2 over 2. So the cosine is the square root of 2 over 2. And the sine is the square root of 2 over 2. Okay, so convert to degrees, draw your triangle. If you already know, if you already have your unit circle in front of you, you won't need to calculate this part. You won't need to do the triangle part. You'll already know what the cosine and sine at 45 degrees is. So let's do pi over 6. Okay, so let's grab our unit circle, and let's figure out what pi over 6 is. So we're going to convert first. D over 180 equals pi over 6 over pi. We're going to cross multiply, top to bottom, bottom to top. d pi equals 180 times pi over 6. So d pi equals, we have 30 pi, and then divide by pi, so the pi's cancel. So d equals 30. So now I want you to go to your unit circle, and I want you to look at your 30-degree angle. So imagine your circle, find your 30-degree angle, and tell me what this sine and cosine is. I hope you say square root of 3 over 2 and 1/2. Okay, so 30, right, 60, 90. That spot right there on your unit circle is square root of 3 over 2 and 1/2. All right, number 2, same idea, d over 180 equals 7 pi over 4 over pi. Cross multiply, top to bottom, bottom to top. d pi equals 180 times 7 pi over 4. Again, you're doing all of this numerical portion, and you're leaving pi kind of hanging out by itself. d pi equals 315 pi, and again, when you divide by pi, they cancel, so the degree measure is 315 degrees. Okay, so here's your 0, and down, straight down is 270, right? So that's 270. So I'm going to go a little bit further until I get to 315 degrees. So you're going to look at your unit circle. At 315 degrees, you're going to tell me what the sine and cosine is. So I hope you say square root of 2 over 2 and negative square root of 2 over 2. Good job. One more thing. I know this is a long one. I'm kind of hurrying along a little bit. The last thing is arc length. So I'm going to throw the formula up here for you. So we're going to try to remember how to do this, deriving the arc length of the formula. We're going to let S be the fractional piece of the circumference of the arc length. So notice here that S is the circumference piece, okay? So it's going to be what we use as the top part of this fraction. There's the little piece of the arc length. Beneath that is that is the fractional piece of the whole circumference. So circumference, we know, is 2 pi r, right? So the whole circle would be 2 pi r. I just want this fractional piece of it. So that's like saying S over 2 pi r. I want a fractional piece of the whole circle, the whole circumference. And the same thing goes for the degree measure with the angle. I want that theta, however many degrees, out of the whole circle, which is 360 degrees. So this fraction represents the degree part, and this fraction represents the circumference. Okay? So the first fraction represents the fractional part of the circumference, and the second fraction represents the fractional piece of the degrees. Okay? So if I want to find A, in this first example down here, I am going to use the formula S equals theta times r. Okay? Theta times r. And the reason is, when I cross multiply these guys, everything's going to cancel out. The 2 pi is going to cancel out with 360 degrees, because twice 2 pi is a whole circle, and 360 degrees is a whole circle. So we're going to end up, when we cross multiply on this side, with just an S. And when we cross multiply on this side, we're going to have O and R left, and that's it. So after we solve this formula, we end up with this. So this is our formula for arc length. Okay? That's the one we use. So I'm going to do down here, S equals theta times r. So first of all, what's theta for this section that says A? That's theta, 5 pi over 6, times the radius of the circle, and that is 3. So you are going to take your calculator out, and you're literally going to do 5 times pi times 3, and then you're going to divide by 6, and you're going to get 7.9. When we want the length of the arc, we usually give it in a decimal form as opposed to just leaving it in fraction form with pi in it, okay? So we're going to do the same thing with b, so I'll do that in a different color. So now I want this one, so I'm using this theta, so I have 2 pi over 3 times the radius, which is 3. So again, on your calculator, 2, hit the pi button, times 3 divided by 3 equals 6.3. Now, I do want you to use the pi button on your calculator as opposed to just typing 3.14, because remember, when you use 3.14, you're rounding it to a certain value, and you're making it less accurate. So hit that pi button and let it go all the way across the screen and get as many digits as possible so you're not rounding quite so much, okay?